Alright, next concept is fourth part, test statistics. After setting up the hypothesis and after fixing the level of significance, we have to calculate the statistic from sample values to test the hypothesis. Depending upon the nature of the data and nature of the problem, we use normal distribution, t-distribution, or chi-square distributions, or chi-square denoted by this symbol distribution, right? Test statistics can be defined as the statistic calculated on the basis of appropriate probability distribution for testing the hypothesis, right? So we most commonly use the test statistics as, first is Z distribution. Now Z distribution will be used when if the parent population, that means जिसमें से आपने सैंपल लिया है जिस पॉपुलेशन से, if the parent population can be considered at least approximately as normal distribution, and if एक और condition है that if the sample is large, large means what? Number of samples is greater than equal to 30, right? Then we calculate the Z statistics as Z is given by x bar minus mu upon sigma upon square root n, where x bar is sample mean, है, mu is population mean, sigma is standard deviation of population, and n is size of the sample, right? Next distribution is t distribution. This t distribution is used when your sample size is less than 30. If sample size is small, that is n is less than 30, then we calculate test statistics by this formula: t is equal to x bar minus mu upon s upon square root n minus 1, where again x bar is sample mean, mu is population mean, to be tested, s is standard deviation, of sample, and n is size of the sample, obviously less than 30. Next distribution which we may use is chi-square distribution. Now in chi-square distribution is used to test the goodness of fit, or to test independence of attributes etc. We use test chi-square statistic as chi-square is given by summation O minus E. O means observed frequency, E means expected frequency, divided by E. This is the formula, where O is observed frequency, E is expected frequency, of an event or cell. Next concept is selection of test statistic. Selection of test statistics. Now this concept statistic is more clearly or more simplicity given by this table. This table says that this is sample size, then next is population standard deviation, sigma known, second is population standard deviation, sigma unknown. Right? First is that n is greater than or equal to 30, any population. If n is greater than or equal to 30, then we have to use Z test. If population standard deviation is known, and if it is also unknown, then also we can use Z test. Right? This is the first part. If n is less than 30, this is population normal or approximately normal. Then in this case, if n is less than 30 and if population standard deviation is known, then again we have to use Z test. But if sigma standard deviation sigma is not known or unknown, then we use T test. Right? Question number page number 5, then page number 6. Next concept. Next is making the decision. Now in making the decision, we have to understand only one thing. Making decision. In this we compare the calculated value Z calculated and the tabular value Z alpha, also called as critical value. Note that the critical region may lie on one side or both sides of the sampling distribution of test statistics. The area of critical region in the tails is equal to level of significance. So there are next part after calculating and Z alpha, there are two more concepts. First, two-tailed test and one-tailed test. Two-tailed and one-tailed test. The probability distribution of a sample statistic is normal distribution. This must be clear. This is normal distribution. The Z curve is symmetrical as we know, and the parts of the curve at the two ends. I'll just write down. This is what we are talking about. Z curve, as it is a normal curve, normal distribution. So the Z curve is symmetrical as we know, and the parts of the curve at the two ends. Two ends means these ends. Parts at the two ends are called two tails of the curve. These part are called as two tails. This and this part are called as two tails of the curve. If the rejection area lies on the two sides, that is on the two tails of the test, is called two-tailed test. On the other hand, if the rejection area lies on the one side of this curve only, then it is called as one-tailed test. Let us see one by one what is meant by two-tailed test and one-tailed test. In two-tailed hypothesis, the rejection area lies on two tails of the distribution. For example, while testing, null hypothesis, let's say, is given by H0 is mu is equal to mu 0. Alternative hypothesis HA will be the negative or the reverse, or what you can say, mu not equal to mu 0, right? Now mu is not equal to mu 0, that means what? Either mu is greater than mu 0 or mu is less than mu 0. These are the two possibilities, right? So we use areas on both sides, and hence it is called two-tailed test. Next concept is one-tailed test. One-tailed test. In one-tailed test, we use the area lying on one side of the normal curve. When an alternative hypothesis is one-sided, for example, we'd use mu is greater than, either mu is greater than 0 or mu is less than mu 0. The test is one-sided if we use any one out of these two, right? Now in this there are again two parts: right tail test, and second is left tail test. Left tailed test. Right tail test means what? The region lies over here. Left tail test means region lies over here, right? So if the region of rejection lies on the right hand side of the normal curve, the test is called right tail test. On the other hand, if the region of rejection lies on the left of the normal curve, then the test is called left tail test, right? Now we have the next concept, that is table of critical value. Table of critical value. This is for normal distribution. Note that in this module or this last sample test, we are going to use Z test only, right? So let us write down the table first. Name of the test. This will be two-tailed, one-tailed. Next is critical value. Z alpha equal to 1.64, Z alpha equal to 1.96, Z alpha equal to 2.33, Z alpha equal to 2.58, right? These are the critical values. Two-tailed test. Two-tailed test. Level of significance, LOS. Then alpha is equal to 10%, alpha is equal to 5%, alpha is equal to 2%, and alpha is equal to 1%. Then one tail test, right tail test. Again level of significance. Then LOS, alpha will be 5%. Here alpha is 2.5%, alpha is 1%, and alpha is 0.5%, right? Next is left tail test. Left tail test. Alpha is 5%. This is again 2.5%. That means these two values are same, 1% and alpha is 0.5%. Note that Z alpha for single tail test, either left or right, single tailed test, left or right, at a level of significance alpha is same as critical value of Z alpha for a two-tailed test at a level of significance, LOS, at a level of significance 2 alpha. This is the important result. Next concept is errors in testing. Next concept is errors in testing. Page number 7. Now, while solving these examples or while finding the errors in testing of hypothesis, in solving example or checking whether the hypothesis or assumption is correct or right or wrong, there might be some errors, right? So what are those errors? Let us say H0 is your null hypothesis, right? Just a second. H0 is null hypothesis if it is true. H0 is true, and if we accept it, H0 is accepted, then your decision is correct, right? If it is true and we have accepted it, then correct decision. But what if H0 was true but you have rejected it, is rejected, then in this case you make type 1 error, right? Next, if H0 is false, that means your null hypothesis is false and you have accepted it, then you commit type 2 error. But at the same time, if your null hypothesis is false and you have rejected it, then your decision is correct decision. Correct. Now next thing is, we shall now see how to test a hypothesis or assumption. We shall consider only two cases, two types of samples. First is sampling of variables. Let us say testing of hypothesis. We will consider only two samples. First is sampling of variables, and second is sampling of attributes. Right? Let us first of all see sampling of variables. I know this is theoretical, but now we are in the last phase of the theory. After this we'll start with the examples. We have already seen that the sample mean x bar is normally distributed with mean mu and standard deviation sigma upon square root n, where mu is population mean and sigma is standard deviation of population, right? So next concept is testing of hypothesis that the population mean is equal to mu. Testing of hypothesis that the population mean is equal to mu. Alright, let us see one by one. This concept is testing of hypothesis that the population mean is equal to mu. Suppose that the standard deviation sigma of population is known, and let the null hypothesis to be tested, that is h0 is equal to mean is equal to mu if x bar is sample mean, then x bar is distributed normally with mean mu and standard deviation sigma upon square root n. Hence this z is given by x bar minus mu upon sigma upon square root n is a standard normal variate with mean 0 and standard deviation equal to 1. Right? Now we take a sample and find mean x bar. We take a sample and find mean x bar. If the observed mean x bar is such that this value of z, that is x bar minus mu upon sigma upon square root n, absolute value of this exceeds 1.96 numerically, if this value is greater than 1.96, then a rare event has occurred because the probability of this is very small. Okay, modulus z will be greater than 1.96, right? And therefore, because table से हम लोग देख सकते हैं that probability of this modulus z greater than 1.96 is nothing but 0.05, right? And therefore we say that the relative deviation of x bar from mu is significant and not due to sampling fluctuations alone. We therefore reject the null. अगर ये value greater than 1.96 हो जाएगी, then we reject the null hypothesis at 5% level of significance. Therefore you can write that h0 is rejected at 5% level of significance. Right? Note, one important note is that if the standard deviation sigma of the population is not known, and if sample size n is large, अगर सैम्पल साइज, अगर आपका स्टैंडर्ड डेविएशन जो है सिग्मा और पॉपुलेशन का वो पता नहीं है एंड सैम्पल साइज जो है वो लार्ज है, दैट इज n greater than equal to 30, then we can use standard deviation s. Then we can use standard deviation s of the sample in place of sigma. अगर आपको पॉपुलेशन का स्टैंडर्ड डेविएशन नहीं पता है और अगर आपका जो सैंपल है जिसका साइज लार्ज है n greater than equal to 30 है, देन आप जो है सैंपल का स्टैंडर्ड डेविएशन s यूज कर सकते हो फॉर फाइंडिंग और फॉर सॉल्विंग द एग्जाम्पल. राइट?